Alright guys, let's continue. So this is kind of the second part of the problem solving. In the previous video I just did a part A where I was talking about the type 1 problems, and I just give you a concept of reference angles and stuff like that. And now let's do some real problem solving. We had a lot of fun. Like I said, a lot of concepts. If you're lucky, you may not never get in the exam, but if you know the concepts, you can make sure that whatever you write in the exam is solid and you're not going to lose any marks for that. Okay, so with that, let's move to the second part of the video. Okay, we covered up to here all the things that you saw. All right. Okay, so I've just copied the reference table for us, just for reference check so that you can easily move the values. Okay, so for type 1, out of the 7 types of problems that you might get in the exam, for type 1, I just pulled out the problems from the question papers for last 4 years, and I also checked your some of the syllabus books. So 95 to 96 percentage of the time you're not going to get any more problems than just these two types. This out of the 4 papers that we are seeing here, over here, this and this are repeating for the, and the first and the last are repeating. So you basically, they're just two kind of varieties of type 1 problems that you need to understand, and that's the beauty of when you put it into type, it's kind of easy, very easy to remember. And I'll explain you how to solve that, and you're not going to get any more than that. And there are some variations of these problems that I've just explained you just in case sometimes the examiner might be just goofy and trying to just say, okay, I'm going to trick the students. In case he does that, you'll be still covered, but assume that 90 to 95% of the times you're not going to get anything outside of this. Most of the times you might just get the very exact problem that you're seeing here, or a slight variation of this, but not too much of a variation of that. Okay, so now why these problems are interesting? First of all, trigonometry is as such, and this type 1 problem both, they're very interesting. And why I would say, because of the scoring methodology and some of the tips that you need to know. When they give a trigonometric problem to solve, for the timing, let's assume that we are working on the type 1 only. So let's assume the type 1 sum and difference formula that we saw in the previous video. What is that sum and difference formula? If you see here, the cos a plus b and the sin a plus b or minus b, those two formulas for the time being, ignore the tan. So these are the sum and the difference formula. So all of type 1 problems will have to apply this formula, and as long as you know this formula, you can solve the type 1 problems. And the beauty of these problems, specific in type 1 and also pretty much applicable to the whole of trigonometry, and that's the reason I told you in the previous video that trigonometry is one subject that you should master, because it can pretty much cover you for most of the passing marks. The nature of the problems are such that the hints will be always in the question. So if you see here, the hints will be given in the question itself, and I'll tell you what that is in a minute. And the second thing is, whatever is the answer to the question will be already given in the question. So the question itself will tell you the answer. That's the beauty of it. That's like silly, but it works in your favor as a student. The question will give you the answer, and they'll just ask you to prove it. That's it. Hey, this is a question, this is the answer, why did you prove it to me? So there is no way you can go wrong with that, because the answer is that. Till you get the right answer, you just make sure that you're working and reworking on that one, and that way your marks are sealed. Whereas in other type of problems, you don't know whether the answer is right or not. So like I said here, you can get the answer, you can use your calculator to fix the errors, make sure the answers are correct, because the answers are known up front, right? That's the beauty of that. And across maths, not only for trigonometry, not only for type 1 problem, remember one thing for sure. Anytime you're unsure about anything, you don't know what you're going to do, how to attack the problem, don't worry about it. The first and foremost, or at the least, let's say you're running out of time, the time is up, you need to surrender the answer sheet, or you know what to do but you're not sure, don't worry about that. All you do is write down the formula that you think is relevant to the problem, because each formula carries a mark. Every mark counts. If you write a formula, you're sure that you'll at least get 1 mark or 1.5 marks for just writing the formula based on what is the complexity of the formula. So always remember that this is super crucial. Always write down the formula in the exam. even though you're not sure, okay, you think that, okay, now what, I'm not going to make this problem. The time is up, it's last 2 minutes, last 1 minute. Don't worry, just write the sum number and just write the formula. Think that, hey, for this I need to apply a sum and difference formula, or for anything and everything in maths, whatever that formula is, just write that. And after that, if you have to give back the answer sheet, that's okay, but you still got the marks, right? So always remember that. So these are some of the tips and tricks that I would apply. All right, so now coming back here, if you see here, like I said, there will be only two varieties of problem that you will get under type 1. One is this that I've highlighted, and one is that summer 2019 and that this thing. So the first and last are one kind of variation, and the second and third are kind of one kind of variation. The second and third are very easy. It normally will come for 2 marks. I've written it here. So if you see here, the question number 1 and C for reference, I put 2 marks, and it's very easy. So let me first try to explain you that, and then I'll come to these two problems, and then you can solve that. Okay. All right, let's go down, 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 down. Okay. All right, so like I said, the hint will be always in the problem. Let's see what I mean by that. Okay. So over here, like if you remember here, I told you that you'll always have the tips and tricks here, right? The hints are always in the question itself. So let's try to apply here. So the question reads like this: without using the calculator, so you cannot use the calculator, find the value of cos of 105 degrees. That's the question that you get. Now, so let me explain you what I mean by the hint are in the question itself. Okay. So when I say the hints are in the question itself, it's talking about cos of 105 degrees. So does it make sense to me? Can I apply a sum and difference formula? Possibly yes. And I'll come to that why there is a hint in the formula. For example, if you see here, find the value of sine of 15 degrees using compound angle. That's your hint, right? As soon as say compound angle, then you know, oh, aha, compound angle is type 1. Type 1 is all about compound angle is same as sum or difference formula. And I know that I need to use this formula. So if I write down the formula, I'm going to get the marks, and based on that, I'm going to solve this problem. That's number one. So in this case, they are not given compound angles, but as you practice, you will know the pattern, how to identify that. But by and large, you'll get some hints in the question. That's number one. So this is what I was trying to say. Boom. The second thing, the answer is already given in the question. What does it mean? Find the value of sine 15 using compound angles, and over here, without using calculator, find the value of cos 105. So once you do whatever magic without using the calculator, you can always verify. No one is going to stop you from verifying what is the answer using the calculator. You just don't have to write it in the exam, but you do all your examination tricks, open up the calculator, calculate the value, and see whether it matches. If it matches, you're on the right track. That's what I mean, that your answers can be always verified. Okay, whether they want it or not, you can use the calc to verify the answer, and that's the beauty of that. What else you want? The hint is in the question, the answer is given, you have to just solve it. And that's the beauty of trigonometry and maths in general, but trigonometry gives you the flexibility of easily attacking that. And as long as you remember that, okay, the answer, just read the question twice, you will get the clue. Okay, so that's what I was trying to mean from the hints are in the question and the answer is already given. Okay, so now let's go back. So let's take the let's take which problem? Okay, hold on. Let's take okay, let's take this problem. Okay, for that, because the answer is hint is already given. So now the question is, find the value of sine of 15 degrees using compound angles. So I've got the hint. I know it's compound angle. That means I need to use a plus b kind of formula. And since I need to do it for sine, that means I need to use sine a plus b. So I've got the first hint. Okay, number one. Number two, it's talking about sine 15 degrees. Okay, sine 15 degrees. So I know that sine 15 is going to be in quadrant 1, and hence it's going to be always positive. So whatever is the answer I'm going to get based on the cast formula, if you remember the cast, sine is always going to be positive in this quadrant, right? So whatever is the value, if I get negative, that means I'm wrong. So I've got the hint. Okay, I'm going to use this formula, hint number one. Sine of 15 degree, it should be positive, it cannot be negative. Okay, so that's the hint I put here. So in the exam, when this problem comes, that's how you need to think. You just need to take a pause, read the question, frame your mind, and then attack. So the first hint, sine 15 should be positive and it's in quadrant 1. Second hint, the question itself says to use the compound angle, and you know what you're going to use, the formula. Okay, so what is the first thing you do? Like I said, the very first thing you do, whether you know or you don't know, whether you have time or you don't have time, is is writing down writing down the formulas, because that's the first thing you'll do for any problem. Okay, every mark counts. So what I'm going to do, I'm going to talk about 15 degrees, so I'm writing the formula, sine a minus b. So what is the typicality of this problem, like other, whether you take sine 15 degrees or the previous problem that I saw here, 105 degrees? How do I know that? I know I need to apply compound angles, but how do I know what I do with that? Always remember, you know the reference angles concept, right? The 60, the 30, the 45, the first quadrant that we spoke about, anything and everything here. This angle, this concept. So if you think, you can easily take, if they're asking about 105 degrees, or if they're talking about 15 degrees, and if this is your a plus b or a minus b, can you find out two angles, two individual angles, a and b, which should be a reference angle? That means it should be less than between 0 and 90 for sure. And more than likely, these are the three values: 0, 35, 30, 45, 60, and maybe you can count 0 and 90. So these are the five values that you have. So using these five values, more than likely, or maybe using these three values specifically, can I make two angles that will either add up to this angle or that will subtract and give me this value? Can I do it easily? If you can do easily, always remember that it's a problem of type 1 sum and difference formula. If you cannot do it easily between those two angles, between the reference angles, set of reference angles, that means it's not a type 1 formula. That means you cannot apply that formula, or you have to do something else. Always remember that. So in this case, over here for cos 105, if you see here, cos 105 is 60 plus 45. Both are less than 90 degrees. I know the values of both of them. I know what is 60 degrees, I know what is 45 degrees. I know the formula. 60 plus 45 makes 105. So yes, it's a type 1 problem, because I can easily break down the individual angles within the reference angles framework, within 0 to 90, between 0 to 90, to make this angle, apply the formula and calculate. And in the case of the sine 15, I can still find two angles, 45 and 30 degrees, or it could be 60 and 45 degrees, doesn't matter, the answer is same. So I can find two individual angles, which either I can add in the previous case or subtract in this case, to give me the angle that is being asked in the question. For example, over here they're asking find the value of sine 15, and sine 15 degrees is nothing but 45 minus 30 degrees, and both 45 and 30 degree individually are a part of the reference angle that I talked about, for which we know the value. So that means I know this is a 100% type 1 value, because I can apply those two things and calculate it easily. And the next step is just magic. You have the formula sine a minus b. Remember I told you, for sine, when the sign, this particular algebraic sign always says the same, whatever it is. And in the case of sine, you have sine and cos on either side. So sine a minus b is sine a cos b, minus, because there is a minus here, cos a sine b, and you put that, and you know what is a and what is b from here, because the 15 degrees you have broken up into compound angles, and the compound angles are 45 degrees and 30 degrees, where you can say this is a and this is b, right? And if you apply that to the formula over here, sine a is 45 and then cos b is 30, and you continue the formula, you know from the reference table what are the formulas. These formulas I already told you how to memorize on this, right? And it's easy to remember. And if you just apply it over here, all the formulas over here, and just do the substitution, keep on doing substitution, you get some value. You get the value as 0.258. That's the answer. Now, typically in the exam, you can say, oh, I got the answer, and you can move on. This is for 2 marks. I think I got it right. But here is where whatever concept I explained to you so far of reference angles, reference triangles, and stuff like that, which I told they are not going to ask in the exam, but it's useful and it comes handy, is how do you make sure that whatever answer you have got is correct? How do you make sure? So in this case, I don't have to apply the concept of reference angle because the problem is straightforward. So all I'm going to do is I know sine 15 degrees. Okay, I know sine 15 has to be positive. Okay, am I getting positive here? Yeah, is it positive? Because sine 15 falls in the first quadrant, which is always going to be positive. And they have said not to use CALC, but you know what? I'm going to use CALC, and I'm going to calculate the 15 degrees here and see what is the value of that sine function. And it says 0.258, and let me see whether the answer is matching. Yep, the answer is matching to 0.258. That means I've calculated this value using the formula like they have asked in the question mark, but I have also did a bit of cheating on the side to use the calculator to see if the answer matches, and that's why I put it here. If you see here, the answer matches, right? And that way I can make sure, ensure, double check my answer is correct. So just doing that extra step using the calc and doing some magic to verify that is a good step, and that will kind of give you an insurance of 2 marks complete. You're not going to lose anything. Okay, so the same with this problem. I'm not going to walk you through the complete thing. I've put everything here. You can see that 105 degrees can be broken into two individual angles, 60 and 45. So 105 is nothing but a compounding of 60 degrees and 45 degrees, and they're asking cos 105. You can apply the formula cos a plus b, and you know the values of cos 60 and 45. You substitute that, ta da ta, then you get the value of minus 0.25. Why do you get the value of minus 0.25? Because the hint is in the question itself. Like I keep on saying, that if you see 105 degree and if you apply the cast formula, so 105 will come in this angle, right? And you know this is quadrant 2, and cos is always negative in quadrant 2. So while calculating, if your answer is not coming negative, that means you have gone wrong somewhere. That's your first hint. But in this case, your answer is coming negative, which is a good thing. But how do I know that minus 0.25 is the right answer? The trick here is the easy cheating trick here is just open up the calculator, put cos 105, calculate the value, make sure it matches here. If the calculator is showing a different value, that means you have done something wrong and you need to fix it. And that's how you get your 2 marks. So these are the type of problem that you will get. That's number one. Now the other type of problem that you get is this type over here. If you see the first and the last type, where they might be giving you a couple of angles and ask you to find this angle. So let's try to solve this, and this might have a bit of variation. I'll give you the variation, but like I said, 95% you will exactly get this the way it is, the same values, and then you can easily calculate. So if you can just kind of keep on practicing, you will just work like a clockwork, and you'll go smoothly on the exam. So let's understand this problem, how to break it. I'll explain one in detail, and then I'll speed up the other one so that you know and you can rewind this video and watch it. Okay, so now let's get back to the problem. Okay, now let's say you're in the exam and you get this problem like this. I'm going to read it out for the benefit. It's for 4 marks. Hey, it's 4 marks, so better pay attention. Okay, if angle A and angle B are obtuse angles, and sine A is 12 by 13, cos B is negative 4 by 5, what is the value of cos A plus B? Now I'm writing the exam. It's like quiet in the room. Everyone is focusing on that when this problem comes, and I need a minute to process. Okay, what are they talking about? I know this is something to do with trigonometry. Let me spin my wheels. I've got the magic of the types of problems, and this falls in type 1. Why would it fall in type 1? Let me see whether it falls in type 1. So the hint is they're asking me to find a value of cos A plus B. A plus B. A plus B. Looks like a sum and difference formula. Yep, that is correct. It has to be type 1 because they're asking about that. A plus B. Okay. Do I need to do anything else? Nothing. So let's see. Okay, let's keep going. So that's a good thing. And they are given sine of A and cos of B. Okay, so A plus B. So what is the first thing I need to do? Like I always say, the first thing you need to do is write the formula. Okay, write the formula. So if you write the formula, cos A plus B is equal to cos A cos B minus sin A sin B. Like I've told you in the case of cos over here, the sign always changes, right? So you change the sign. On the left side of this sign you will have both cos, sorry, I'm using the sine and sine function and algebraic sign, so let me kind of say algebraic sign, negative sign. On the left side of negative sign you will have both the cos functions, on the right side of the negative sign you will have both the sine functions, so that you'll put. So if I write this function, what does it give me? Look at here. So sine A is given in the problem over here, cos B is given in the problem over here, and I need to find cos A plus B. So that means out of these four values, 1, 2, 3, 4, two of them are given, and if I get the remaining two, which is cos A and sine B, which is missing right now, but if I find that out somehow magically, then I'll be able to compute the value of cos A plus B efficiently. So that's a good thing. Okay, great. So let's go and find out what can we do about that. And like I said, every in trigonometry or any problem, every line is important. Over here they have say given A and B are obtuse angles, so don't ignore that. I've highlighted it. Obtuse angles, what does it mean? Obtuse angles, obtuse angles are greater than 90 and less than 180. So that means the angle should be somewhere in this quadrant, both A and B. That means both A and B individually are in quadrant 2, and by the cast logic, in quadrant 2 both the angles, this value of sine function will be always positive. Is it positive? Yep, it is positive. And the value of cosine is going to be negative. Is it negative? Because the value of any cosine function in the second quadrant is going to be negative. That's great. Now I need to find the value of the compound angle A plus B. But always remember, just because these individual angles are in this quadrant, you do not know for sure where will this A and B will fall. It could fall, obviously it's A and B, so if you add this both angles, it's going to be more than this, right? It's going to cross go into beyond 180 degrees, but it can go here and it can go here also, so you don't know yet where it will fall. So just hold on to the thought. That's where the reference angle comes in, because you might have to figure that out, but you know for sure that okay, if I'm going to add up two angles, it's going to go beyond that. That's for sure. Okay, so you got two hints in this thing in the question. One is I need to apply the sum and difference formula, or this is a type 1 problem because they are given cos A plus B. And the second hint they are given is they're obtuse angles. That means the individual angles all fall in the second quadrant. Okay, second quadrant. So I've got those two hints, and from there let's move on. So I've drawn the cast diagram here. I've told you, which I already told in the video right now. A and B are obtuse, greater than 190 and this thing 180, less than 180, and that's the reason it should fall in second quadrant, where sine is positive and everything else is negative. So now let's take the two values that they have given and let's find out the two missing values. And you know the classic Pythagoras theorem that you can do, and you can always apply that. So let's take cos B. Cos B is given as minus 4 by 5, minus 4 by 5. So if I draw a triangle, right angle triangle here, okay, and if you see this thing, so if I make this angle 4 by 5, so cos is adjacent upon hypotenuse, and then you will see here adjacent is 4 and hypotenuse 5, so it's 4 by 5. Don't worry about the negative sign. The negative sign is coming because it's in the quadrant 2, but when you apply the Pythagoras theorem, since Pythagoras theorem is a sum of squares, if you remember, a square plus b square is equal to c square. Because of the squaring effect, the negative sign will not have any impact, because when you put negative into a square it becomes positive. And based on the Pythagoras theorem, you can find the third angle. So you have given 4 and 5, you got 4 and 5 here, so now you know the opposite side is 3. And now since you know the opposite side is 3, you can easily find the sine B. The value of sine B is opposite upon hypotenuse. Remember, you have to find the value of sine B, the missing value. So you found that 3 by 5. Now this is where the trap is. You always remember, okay, finding a value is one thing. Okay, there are always two things, two-step process. Find the value and apply the sign, apply the algebraic sign, whether it's positive or negative. Okay, now you got the value here, but you know angle B is in second quadrant. The hint they've given, because it's obtuse angle, and if an angle is in second quadrant over here, if you see the cast formula over here, right? Sine is always going to be positive, so hence the angle of sine B is going to be 3 by 5 positive, so I can retain the positive sign. That's a good news. Similarly, I can take the second value, sine A is equal to 12 by 13, which is what they have given, and I'm going to use that to find the other value, cos A, and same by applying the Pythagoras theorem over here, I can find the value of cos A and 5 by 13. But here it's tricky because cos in second quadrant, also angle A is also in second quadrant, they have given that, right? Over here if you see angle A and appear obtuse, since both the angles are in second quadrant, and if you're going to find a cos function, use a cos function in second quadrant, is always going to be negative. So you find the value first and you have to apply the negative sign here. So this is the trick we have to apply. If you go wrong here, you will go wrong, and based on our reference check or using the calci, you will have to come back again to make sure where you missed it. This is the biggest trick here. So while calculating the Pythagorean sides, don't worry about the negative sign, but apply the negative sign based on the hint given in the problem. In this case, it's negative here, you got it. The other thing is to save time. Normally, if you remember the concept of Pythagorean triplet, 3, 4, 5 is a triplet, 5, 12, 13 is triplet. So if you get these easy ones, looks like in this exam, both the questions are a triplet formula. Don't even calculate the theorem, just say by Pythagorean triplet, save your time, saves 3 minutes, draw the triangle, put it, be done with that, but don't forget to apply the algebraic sign based on the cast logic. So now you have all the values that you need for this. You need 4 values, you got all the 4 values based on the simple logic, and the next thing is just substitution. So you have it here, you substitute, this was given to you, this was given to you, sorry, this was given to you, this was given to you, this you derived, same here, you put the formula, you make sure that you taking the negative, you do all the substitution, you come here, cos A plus B, it gives you negative 16 and 65, and the value, if you do the decimal point, it comes to negative 0.2461. So the value is negative 0.2461, and negative is okay because you know that cos is going to be uh, not in this quadrant, it's going to be somewhere here and here. But now since you know that cos is the cos function is negative, that means it cannot be quadrant 4 because cos of any function in quadrant 4 is positive, whereas you are getting here as a negative value, and cos is negative only in 2 quadrants, either quadrant 3 or quadrant 4. That means it has to be in quadrant 3. The angle, if they ask you in exam which quadrant the angle falls, for sure it's going to be in quadrant 3, because it cannot be in quadrant 2, because you're going to sum the two angles, it's going to be more than that. That's the logic. So I have written here that it's going to be in quadrant 3. But now think about it. Let's say if you do some calculation mistake here, anywhere here or anywhere applying the formula, or you missed negative sign, anywhere in this step you miss one small thing, this value will be different, whether it's negative or positive doesn't matter. How do you know that you got the right value, both from a value standpoint, like minus point the numeric value, and how will you know the sign is right? Because based on this sign you will determine the quadrant. How do you know that? You do not know that yet, and that's the reason you just spend 2 more extra minutes to do a quick check. It's not required for the from exam standpoint for you, no one is going to ask you, it's kind of a detour you take, you spend 2 extra minutes, but it secures you 4 marks, because there are high chances that you might be doing some calculation mistake here. You just want to make sure that I got this correct. Okay, so how do I do this? Okay, this is where the concept of reference angle comes. So this step 3, if you see here, step 3 is just a checkpoint. You don't have to write it in the exam, you can do in a rough paper and put it, no one's going to ask you. If they ask you to find the quadrant, then it will help, otherwise it's fine. And this is more of, again, kind of a cheating, because you're just kind of reverse engineering and trying to do that. And how I'm cheating this? Okay, now the cos of the angles are given. Okay, cos A and cos B is given. So using the concept of reference angle, or in any other way, easy way, if I can find the actual value of A and B, and using calculator just apply a cos function, I should get the same value. That's the whole logic, right? So what I'm trying to do here, I have cos A is equal to minus 5 by 13, and I have the B as minus 4 by 5, which is given in the problem. I'm going to use the inverse trigonometric function. The inverse trigonometric function I have not taught you yet, but by the time you finish up this chapter, you'll know what is the inverse trigonometric function. But it's a simple thing. If you have given the value, how do you inverse it? Like how do you get the angle of from the value derived? So you apply the calculator logic, do the inverse function. So what is the angle A for which cos A is minus 5 by 13? When you apply that, you get 112.619. Likewise for B, you get 143.130. And in this case, you're lucky because both the angles are in second quadrant. And in second quadrant, since in second quadrant, it has to be more than 90 degrees and it has to be less than 180 degrees, which pretty much matches. And the calculator sometimes is funny. It will not give you the exact quadrant. In this case it gives, but this is not the right way to do that, because I'll explain you in the next problem why it might goof up. But assume that you use the calculator, because I have not applied the logic of reference angle here. You should Reference angle is the right way to do that, but in this case the calculator gives the right value because the negative value of causes, it's in second quadrant. That's reason it's very easy to determine. But otherwise you should apply the reference angle. That's a foolproof way. Always remember that. So anyway, you got the angle A and angle B. You know that's going to be obtuse. These both are obtuse, greater than 90. When you add A plus B, you get this value over here, which I've highlighted in the blue color, 255 degrees. And if you take the cos 255, which is A plus B, you get this using the calculator. You get this value, negative 0.25461, which matches with this. So this value matches with this value, and hence you are not wrong. You are right there. You have secured your 4 marks. And based on this calculation, since the A plus B is 255 degrees, remember I told you that it has to be quadrant 3, because cos is positive here. It cannot lie in second quadrant because you're going to add 2 angles. It's going to overflow. But we wanted to make sure that our judgment is correct. It's in the third quadrant, and now you're proved, or you're sure that's in third quadrant. But in exam, I don't think you can apply this logic, although technically it's not wrong because you can apply it, but I'll tell you how to do that. But using a cheat code of calculator, you can quickly do this for 2 minutes and make sure your answer is right. If for some reason this number that you got hit here based on this angle is not matching over here, then somewhere you have gone wrong. Either here or here, you need to double check, and that's the reason this method is easy. So based on this, you got the value, you know the quadrant, everything is sailed, 4 mark is good, second 4 marks, you are inching towards your passing marks or maybe more. So, okay, that's how this problem was solved. And this problem has the same variation over here. We were trying to solve this problem, cos A plus B. And in summer 2018, if you see the same angle, if you see them, they are not even changed the words. A and B are obtuse angles, A and B are obtuse angles. And over here 12 by 13, they use a 13. Remember I told you the Pythagorean triplet, so the missing angle is going to be 12, 5, 12 and 13. Same here, cos B is 4 by 5. The missing angle using the Pythagorean triplet is 3. Only thing is they have asked you to calculate sine A plus B. You can apply the same logic and calculate it. I've solved it for you. You can refer it anytime. The same logic over here. And like I said, the hints are there. A plus B is a compound angle. That means you have to apply type 1. And A and B are obtuse angles. Again, both are in second quadrant. Sine 5 by 13 is positive, which is sure. And if there's a typo, you can figure out because they cannot be in a different angle over here. That's good to go. And you apply the same logic and you solve step by step. You come to up to this point. The value is negative 0.8615. But how do I know whatever I calculated is right or not, and how do I know the quadrant of that? So this extra step that I told you to do, I put it here. Okay, so I've taken both the values A and B, and then you get the value of you do the inverse trigonometric, you get the value of A, you get the value of B, and then when you add both this A plus B, it's roughly 300 degrees. You can round off the decimal, and when you do sine of 300 degrees, it's negative 0.866, which matches pretty much here, and hence it's verified. And you know that 300 degrees, where does it fall? The 300 degrees kind of falls in the fourth quadrant over here, right? Because you know that sine A plus B, sine is always going to be negative either in this quadrant or in this quadrant, and in this case it's this quadrant. So that's how you know for sure although the value of sine is negative, which quadrant it falls, because 300 degrees is absolute number, you know it falls in this thing, and you're using calculator, you derive this value which matches with this value, hence you secure your 4 marks. So that's all pretty much I have for this video, where you just know these two problems. It will give you 4 to 6 marks for sure, and this is how you need to verify. Simple stuff. Get the problem in your mind map. You should have a cheat code saying that okay, this applies to type 1. Type 1 means compound, angles, or sum and difference formula. I know both the formulas. Let me write down the formula. Let me do the magic. Let me not forget to add the negative or positive sign based on which quadrant it is. Let me not forget to verify that using the calculator and cheat it, and so that I can get a full proof. So 95% this is what you're going to get. A slight variation that you may not get, but just keep in mind that if you get, you don't have to panic. So there might be times where in this cases both the angles were obtuse, so it was in second quadrant, that was easy. But sometimes the angles might not be in the same quadrant. For example, if you see here, this was one of the examination problem that came 4 years back. I'm not sure they'll ask, but there are high chances they might ask just as a variation, where they're given you one angle in quadrant 1 and the other angle in quadrant 3, right? Because it's the interval is 5 to 3 pi by 2, and this 0 to pi by 2. So when you know that one angle is here A and one angle is other angle is here B, and if you apply cast logic, you know what is positive, what is negative. Same over here. Unfortunately, it's not a Pythagorean triplet, so you have to, unless you remember this, it's not easy to remember. You have to apply the Pythagoras theorem. A square plus b square is equal to c square, and calculate this formula. It's tan a and tan b, and then from there they're asking sin a and sin b. Like always, write down the formula sin a plus b, so you know that okay, I got 1 mark for the formula. Now I need to chase the remaining 3 marks. For that I need to find all these values, and what I've got is tan a and tan b. Okay, from tan a and tan b, if I apply the Pythagoras theorem, I know which is opposite side, which is adjacent side, and all those things. I can do the magic and get all my missing values however I want it, the 4 values that I need, and then you apply that in the problem over here and get this value. So now this value you're getting is negative. So what they're saying is sine a plus b is negative. Okay, now sine is negative only in 2 quadrants. Either it's here, quadrant 3, or it's here, quadrant 4. But I don't know which quadrant it is, so we will use the same cheat sheet to find out which quadrant it is. I've done that. So the variation that they'll ask you over here is, I've given you the cheat sheet here how to verify that, and then how I figured out. You can read through this and you'll get the value where I've told that the overall angle here I've applied the reference angle concept. So let me explain you for a minute over here what is the reference angle here. So I'm just checking using approach 1 just for my satisfaction if my answer is correct. No one is asking me to do that, but let's say they're given sine A is given and sine B is unknown. So let's say I'm going to uh, uh, hold on just 1 second guys. Okay, okay, correct. So they're asking sine A plus B. Okay, so I've put all the values of A, sine A, and I've just given here example like how to do that sine A plus B. This piece is just an example. Like if sine is given A and sine B is unknown, you derive that and you add that. But always remember, just because of adding those two angles doesn't mean that it will fall in the same angle. It is not, because 30 plus 60, 30 and 60 are in quadrant 1, but A plus B is on the y-axis, so always remember that. But here is the actual logic. I have put it here for the above example. You got sine A, you got sine B, and then you need to find out the sine A plus B. You know that sine A is given in, it is given that A is in quadrant 1, you know that, and hence it is positive. You know that this is in quadrant 3, and hence it is negative sign. So you apply this A is equal to sine inverse, because if it's in quadrant 1, you can straight away apply the inverse and get the angle. So I've got this angle, since it's in quadrant 1, it's 18 degrees, it should be less than 90, so this looks okay. So over here I'm going to find the applying the inverse trigonometry, I'm going to find the angle B. Over here, if you see the angle B, I've removed the negative sign, because if you remember, I'm applying the reference angle concept here, and reference angle is always positive in this angle. So let me find this and then figure out. So my reference angle over here comes to 14 degrees, over here 14 degrees, okay. So but I know that this angle lies in quadrant 3. So what will be the standard angle, what will be the actual angle in quadrant 3 for which the reference angle is 14? And if I draw, as you know, reference angle is always dropped on the x-axis. So if I take quadrant 3 and form my reference triangle over here, so this is 14 degrees, but the standard angle, let me take a different color. The standard angle is going to be green. This is my standard angle theta, standard angle. So what is this is the actual angle, what is the value of that? So this whole thing is 180. So if I add 180 to this 14, so I get this whole angle. This is the angle, actually, sorry, this is the angle here. That's what I have done here. So if you see here, my reference angle, my standard angle is in blue, sorry, my reference angle is here in green, and my standard angle, this is 180 degrees, and this whole thing is my actual angle. So I've added that. So my actual angle, the standard angle, is 194 degrees, because it is right, because 194 degrees falls in quadrant 3. That's correct, this matches that. And now I have the value of B, the standard value of B. So I am applying the standard value of B. A is in first quadrant 18 degrees, B is in third quadrant 194 degrees. If I add that, it's 212. If I take a sine value of that, it gives me negative 0.537, which matches with my answer here. That means my value is correct. I've done that. What is a quadrant? Since the actual value is A plus B is 210 degrees, 212 degrees, I know that 212 degrees falls in quadrant 3, because this is 180, this is 270, 200 will be somewhere here. So this standard angle is, this whole angle is theta is 212. So this is where I applied the reference angle. This is the first time I'm applying the reference angle. If both the angles are obtuse in the same quadrant, second quadrant, it's easy. But if things move beyond second quadrant, you use this. Or the safest way is always use a reference angle concept to get that value. And sometimes what they will do is they will twist the question over here, and they will not ask you to find only sine A plus B. They might trick you like this over here. Let me move this here. Okay, hold on. Okay, so they might trick you like this. They might just give you this, the value of tan and value of B, tan A and B, and they'll give you two angles, which quadrant they fall. So one of these two things they'll ask you. They'll ask you to find sine A plus B, cos A plus B, and the quadrant of A plus B, or they will not ask you to find sine or cos. They'll just say find A plus B and give me the angle and quadrant. But you don't have to worry, just a variation. Anytime they ask such questions, know that they're asking you a quadrant. That means you have to apply the sum and angle formula, and since they're giving you the hint find A plus B, it's a compounding angle effect. What you do is, in this case, in this kind of variations, always find sine A plus B and cos A plus B. That's one way of doing that if they ask you. And see, the hint is they're asking you to sine A plus B, they're asking you to find cos A plus B and the quadrant. So what it means is, if you find cos A plus B and you get a value negative 0.844, but you know that cos is your cos of the compound angle is coming negative, right? Over here, for example, your cos of the compound angle is negative, so that means it can be in quadrant 2 or quadrant one second, which okay, so it can be either quadrant 2 or quadrant 3. That's where cos is negative. And hold on, what I'm doing, okay, or it can be, okay, over here, sorry, all right, sorry about that. So sine A plus B has this value which we have proved, but if the value of sine is negative, that means it can be in quadrant 3 or quadrant 4. I don't know yet which quadrant. But the cos of the same compound angle is also negative, and when it's negative, or when a cos is negative, I know that either it can be this or it can be this. So now, by method of elimination, this is the only place where both the angles kind of seem to come, cos and sine, and hence the compound angle A plus B falls in quadrant 3. This is what they will give you the marks for when they ask you to find cos and sine and hence a quadrant. This is how you will find. The cheat code I gave you using the calc is just for your reference, so always remember that. Okay, and if they ask you to just find a plus b also, like I said, the variation, uh, okay, a plus b, assume that they're asking you to find sine a and sine a plus b and cos a plus b, and that's how you'll determine the angle, because you need to know, you need to prove how you found the angle, and that's the best way to prove that. So in this kind of variations, just find sine of the compound angle, find the cos of the compound angle, use the method of elimination, see where the both the angles fall, and then based on that take a decision. So that kind of sums up all of the type 1 problem that you will get. You don't have to do anything more than this. This itself is more. Just focus on the questions that are coming in the question paper. The variation is just a way to remember, if you remember. Otherwise you can safely, you can skip it, you don't have to worry. These are the things you have to remember. Just two subtypes they ask you, it's straightforward. The answer is given in the question, write down the formula, and I think you should be good to